Welcome back, everybody. Welcome back to the channel. So today we're going to be talking about how to add serialization to your programming language. Now, before we get into that, again, something a little bit off topic, I will put a link in the description below if you want to skip over this part. But I am looking to start the process of actually building the programming language in the language itself. But this new compiler is going to be pretty amazing because basically the way that I'm actually going to do it, and I would actually like you guys' opinions on it. Definitely would appreciate it if you put your thoughts in the comment section below or like the video and let me know what you thought. But basically now with this new compiler, I can pretty much do a lot more things than I otherwise would in C++. Especially now with the serialization algorithm, it makes things a bit more interesting. So I don't want to get too much into detail about the compiler, but some of the benefits of the compilers is actually going to be faster than my C++ compiler. At least that's the goal. And then I also plan to have a lot more features. So basically right now I'm adding a feature where the concept is you have projects in the language. So there's going to be a new command. You can say new project, you can pass it a name, and it's basically going to set up an entire Sharp project for you automatically. Now, if I go up here to the files, so if I go to like Hello World, here's a Hello World example project. Basically, Sharp is now going to start becoming a system where it's actually usable for real world projects and it can actually be used for a real team with multiple developers. That's kind of the goal behind it. So you're going to have a settings.json file, which is basically going to be here. And this is basically going to be all the settings that you could actually put in the compiler instead of writing, sharp C and then putting, whether or not you want to optimize it, what's the library path to your project or whatever, and a bunch of other options. Instead of doing that constantly, you can just put everything in this settings.json file and it just works automatically. I'm also going to have a source folder, which is kind of like Java, where you basically just have a source, your directory, and your source code of whatever. And right now it's just a Hello World program. And then I'm also looking to have, so like there's a build folder, which is going to contain any of the build stuff. So if you have any outputs of files, if you have like a debug version or release version of your file, that's going to be outputted in the respective directory. There's also going to be a generated folder for any generated C++ code, as well as a cache folder. And basically the way it's going to work is once the compiler gets to a certain point, it's basically going to cache the entire state of the compiler. So let's say, you're compiling 100 files and the compiler compiled like 90 of those files, but let's say the last 10 of those 100 files were like broken or something, like you messed something up. What's going to happen is the compiler is going to cache the results of the compilation of all of the other 90 files. So that means if you fix the next 10 files, now it's not going to be this long, but let's say just for illustration purposes, if compiling all the 100 files took, let's say 5 seconds, and then you ended up getting up to those last 10, well, now because all those 90 files were cached, instead of it taking a total of 5 seconds to compile your source code, it should theoretically take about half a second, because now you're basically only compiling a small subset of actual files that you've modified because everything else is cached. So it doesn't make sense to go back through and like reprocess the files if they've already been compiled. So that's a whole nother topic that I don't want to get into, but that's another feature that's going to be coming along in the language. So I'm doing a ton of crap right now just to like make the process a lot easier. So basically the way it's going to work is I want it to be basically you don't really have to understand the system in its entirety for you to actually use the system, because I know Sharp is kind of a little bit convoluted right now. There's a lot of things, there's tons of settings and stuff that you just don't know about. And it's a little bit confusing trying to understand how to use the virtual machine and so on and so forth. So basically now what you're going to do is you can literally say sharp C dash dash new project. And let's say we say new project of hello world. And then let's say we go into this main file, we do some stuff into here. Then once you do that, here, I'm actually going to put it into here. These are going to be the actual commands that you're going to put in. You modify the settings.json file, and you put whatever settings you want in here. There's going to be an official documentation for this as well later on. And then literally all you have to do is say sharp C. So first you'd actually cd into this directory here. Then you say sharp C dash P, which tells the compiler to compile this project of hello world. And that's it. And literally, if you don't want to worry about, then subsequently typing sharp, then running the builds, and then having to find where the file was put, Instead of doing all that crap, you can literally just say sharp dash p and then dash run, and it literally compiles and runs the program for you automatically, and you don't have to do anything. You don't have to understand where the file was located or what options you need to pass to the virtual machine. You just do dash p dash run, and then you're good to go. Now, if you didn't want to cd into the project directory, you can do a capital P and then say hello world, which will be the path to the project directory that you actually want to compile. And again, it's going to pull all of this information and just do everything automatically for you, so you don't have to do anything. Another feature I'm also looking to add into the programming language is the ability to test your programming language at compile time. Basically, what's going to happen is you can create a test suite called, I don't know, some test, and then you can create that test suite at compile time. And what's going to happen is you can put some code in here. So I don't know, let's say is true, and let's say is true is equal to false. Then you can assert the is true field, and if this test fails, like if there's a crash inside of here, if there's an exception, or all test suites are going to return a var, right? So if this test suite fails, you can also return false from the test suite, signifying that it didn't pass. And if any of this code fails, then basically your code won't compile, basically. So you'll get a compiler error, and you can actually, so like if you have like, I don't know, some external variables in here, you could say counter is equal to 10. You can literally access like variables as if you were accessing it during the runtime. And yeah, it's a lot of stuff, but there's definitely quite a lot of things that I'm looking to add to the programming language to just make it a lot better and a lot more robust and more fun to use. So I would definitely love you guys' thoughts on this new system. Let me know if you have any suggestions to make it better. And yeah, so it's going to be a long time before any of this crap gets done because I'm basically rewriting the compiler from scratch again. So keep that in mind. But yeah, this is going to be version 0.3.0. That's going to be the version I'm currently working on. We're currently at 0.2.9. So yeah, so that's going to be it for that. Now let's actually get into the video today that we're supposed to be talking about. So if I go back here and let's see. So we're actually going to be talking about how to serialize source code in the programming language. So when it comes to serialization, some of you guys may be thinking like, well, what's the use case or what's the point of why we need serialization? Well, before we can answer that question, first we need to answer the question of what is serialization. Basically, the concept of serialization means that you're converting a state of an object in memory and converting that to a different state to be restored later on at a later date, to be put back to its original state as if it was always in memory. So that's a bit of a weird statement. So let's actually get a picture to kind of like see what this is, because I know some of you guys are visual learners. So basically, this is what serialization and deserialization is. You have some object that you want to convert to a stream of bytes, and then you can basically take those bytes, which are literally just chars, right? It's just data, and you can put that in a file, you can put it in a database, you can also put it in some other memory location, right? So it doesn't have to just go to a hard resource. You can also basically just take an object, store it in like some array, and then restore that object at a later date for whatever reason. So and when it comes to deserialization, you're taking the data from one of these resources, converting that stream of bytes back to the original object that it was when it was stored originally. So that's kind of the concept of serialization and deserialization. Now, Java does this. There's quite a lot of libraries that actually use this. So let's actually see an example here. So what I'm actually doing is I'm creating a class of A, and again, I'm horrible with names, so just bear with me. I'm creating a class of A. I'm creating a number variable. I'm creating an object variable, a var array. I'm also creating another A class of A. So one major problem that I actually encountered as I was working on this feature is basically what happens if an object somewhere nested down into the source code references itself. Because if you really think about it, right, as you're traversing this object, you're converting all these pieces of data into streams of bytes. Well, if you get to an object that wraps around to the very top of the object, are you just going to go back down and traverse it again and keep doing that and then get a Stack Overflow exception at the low level? No, there's ways to get around that, and we're going to see that in a second. But let me stop rambling and let's just actually see what happens. So we create a n variable, again, very bad name. create an in variable of class A. We set the number to 10. We set the A to a new A class where we only set the number value, and then we set the object to a array of 1, 2, 3. So it's just a numeric array. Now I use this type of instantiation because it's just easier, so I don't have to create constructors and crap. It doesn't matter how the object is created as long as it's created. And then we're going to print out 3 of the values. So we're going to print out, the number value, which is this one, the object value, which is going to be an array of just numbers for right now. I was doing some experimenting with this, that's why it's called object. This can be any bit of data though. And then finally, we're going to print out a.num. So since we created another a class, we set the num value. Obviously, we don't want to check the other values because object will be null and a will be just null as well. So we don't need to check those. And then we do what's called exporting. So in my programming language, I have a concept of exporting, and basically what it means is you're exporting an object to something else. So it's kind of like in C++, where if you want to export some source code to be accessed at a later date through a DLL, it's kind of the same concept. It's just a naming thing for me. It's what I call it. Basically, I'm serializing the data into, now in this example, I'm serializing it into this class.txt file. And that's a file that's down here. And basically this file represents the binary data that represents the actual A class that we have up here. And then what I do is I do a concept of importing, where you basically import an exported piece of data. And in this case, I'm importing it from a file. Now, there's different ways of doing it. I can export this data. So if I didn't want to use a file, I can just say export and then say bytes, get the bytes of data, and then I can import it. And instead of saying import from, I can just import it directly from some bytes. And then I have to convert it because the value that's passed from here is of type object. So I have to convert it to the type we want to use, which is A, which is the type of N. So I could do that as well, but for right now, we're just going to see how we do it on a file. So once we do that, then again, we print out the values. So let's actually compile this to see what's actually going to happen. So go up here, and it's going to take a while, so I'm just going to skip the part to where I actually get to see the output. All right, so it's about to run right now. As you can see, yeah. So now we can kind of see the output of the actual class. So as you can see here, I create or instantiate this class of A and assign it to this in variable. I then export the in variable and reassign the data of the in variable from the imported data coming from our deserialization system. And then I print out the values again, which are exactly the same values as I had above. So we're literally pulling or extracting the values out of this file and using that data to basically rebuild this object. So I'm going to actually show you my API to kind of show you guys how I actually coded it. And as usual, we'll go through every level to just see kind of how it works. So if I go up to export, this is a new folder in the standard library. There's going to be a serialization file here. Now, there's also a concept of export groups. This is a more advanced concept. Basically, an export group, if any of you are curious, is basically a way for you to export a group of objects, and you get to give it a name, and then you can just basically group together a bunch of objects and export it out to a file or whatever, and then you can read them back. So you can write ints, bytes, chars, objects, and then you can read the values back as you wrote them into the object. And yeah, so it's pretty advanced, but to keep this video simple, let's just look at the basics of how it works. So we have our basic export where we pass some type of object and we return an int8 array, which is a char array of data. And that's going to represent the in-memory version of the exported data. So this is exporting it to a file. This is sending it to another memory location. So as you can see, I just push the object onto the stack. I call some random value of a system interrupt. Again, this isn't going to be the same as yours. You're probably going to have a different number. And then I basically move the value of the result, which basically I access this field. And then I basically pop the data onto that field. So I assign this field the int8 array or the byte array. Now when it comes to importing, it's kind of the same. So I basically pass in a string of bytes and I get the data, I push that onto the stack, call some random system interrupt, and then basically pop off the object that is going to represent the imported version of that object. Now, both of these functions do throw exceptions. So if you give it garbage, then it's gonna scream at you. So if you just give it like 1, 2, 3, obviously that doesn't make any sense. It can't import that data. So keep that in mind as well if you are going to be using the system and the programming language. Now, when it comes to exporting files, it's pretty much the same. All I'm doing is piggybacking off of these two functions here. So I request an object for exporting, I request a file name, and then I just create a file with that file name and check to see if it exists. If it doesn't, then I create the file and then I write the data to that file. In this case, it would be class.txt. And then after that, I return the file, so that way you can access it later if you want. And to import, and I had to do import from because the other import also takes a string array. So, if you guys remember, these would be basically two functions with the same types of parameters, so that wouldn't work. So if you want to import from a file, you pass it the file name. It creates a file and it basically just reads the data from that file. It then imports that data using the deserialization software. So that's pretty much it. And of course, these two functions, just like I said, call into these two. So now let's actually go a little bit deeper to see what the virtual machine is actually doing to make all this happen. So if I do a search for operation import, you can see it's basically down here at the bottom. So what I do for export is I pass in the object that's popped off the stack into the export object function, and then I convert that data to a native string, and then I create a string array from that value and push this data onto the stack. I free up the string, and then I call a cleanup function, which just cleans up the resources that was used by export object. When it comes to importing objects, I basically just pass in a object that I want to get the data from, and then I do a cleanup. Now, to make this as flexible as possible in terms of what you can do with it, I'm basically giving it up to the user to basically have to pass in the object that contains the bytes of the data that they want to import or export. This way, I don't have to care where the data came from. They could have pulled it from a file using the file system API, or it could come from memory. It doesn't matter, so that's why I do it this way. Now, let's actually go into the API to see what actually happens. Now, I know some of you are wondering, well, how did you figure out how to do this? Like, is there some resource that I looked at to figure out how to actually serialize data? Yes. So if I go up here, I actually found this website. Now, I'm going to put this as a link in the description below, but I have no idea where I found this from. I do a lot of searching, guys. As you can see, this was posted in 2009, so it's kind of old, but the premise is still there. It kind of basically explains how Java serializes all of its objects using its serialization software. Now, I was actually kind of surprised that it wasn't actually more convoluted than I would have thought of. So let's just kind of go through how Java does it. Now I'm going to go through this kind of quick. I don't want this video to be too long because I do have to show you what I did, because I took a little bit of a different route. I didn't use the same characters that Java did and stuff. So I did my own thing. So I'm going to show you guys that, but let's just go through this really quickly. So basically what happens is when it comes to Java, you have to have the class implement serializable. Now for my language, you don't have to do that. If you want to serialize something, you just serialize it and that's it. And if you're worried about the protection of your objects, again, you can always just use the code obfuscation system. And all this software is going to work with the code obfuscation system as well because of the nature of how everything works. So if you still want to be able to serialize objects and like pull the data out and stuff, and you want to obfuscate it, of course you can do that. Now, if we go down here, so if we keep going down, basically, whenever you want to serialize an object in Java, you have to create a file output stream, and you say what's the output file that you want to output to. You create an object output stream, you pass it the file output stream, and then you create or access whatever object you want to serialize, and then you write out that object. Now, I wanted my system to be a lot simpler. This is why I literally just have one function where you just say export to file. Now we don't have to do all this crap. And then of course you clean up the resources as well. And to recreate the object, what you do is you create a file input stream with the same file. You create an object input stream with that file input stream, and then you basically read an object from that input stream of the object, and then you convert that to whatever object you want it to be, and that's it. So that's pretty much how you do it. And now let's actually see how Java handles serialization of their objects. So Java has a specific format, and this is an example of the test serial format of the class that we're going to be serializing. So when it comes to this, basically, if I scroll down, in short, Java's format as follows. So the first two characters are going to be what's called the stream magic. This basically specifies that this is a serialization protocol. I highly recommend you copy this. Now, it doesn't have to be these two characters specifically, but I would recommend you having some type of magic or secret characters to represent that this is an authentic serialized object. That way, you can process it properly and you don't just end up reading garbage. So once you have that, then Java has the stream version. So this is the version of the serialized object. And then we also have another character that specifies whether or not this is a new object. And then if we keep going down, we can see that the character of 0x72, or the hex character of that, is equal to TC class, specifies that this is a new class. And then there's a couple of bytes for the length of the class name. And then you have the actual raw bytes of the actual name, so serial test. And then you have serial version UID, which is a concept that Java uses. Basically, this allows you to set the serial version of the class. Then we contain, a couple different flags that are particular to the object that supports serialization. And, there's a ton of stuff here. So as you can see, it's basically just picking specific bytes of data to represent certain things. And this is pretty arbitrary, right? Like there's no rule that says you have to use 0007 for the length of a field name. There's no rules that say you have to use 0x49 for the code that basically represents that this is an integer, right? Like these are just random arbitrary values. So you can literally just make up whatever the heck you want. And we're going to see that in a second. That's pretty much what I did. I just made up a bunch of random characters that represent various different things, and yeah, so we'll see that in a sec. But as you can see, it's pretty detailed. So this is a pretty decent article. I definitely highly recommend it. So I will be, like I said, putting this as a link in the description, but let's actually get to how I do it in my programming language. So when it comes to exporting an object, we're going to pass the sharp object that we want to export. Now I have a bunch of these define statements here. We're going to be looking at that in a second. First, let's actually go in here. So I have a couple of concepts. So I have a concept of stream info, and this is basically a way for me to keep track of the actual data that we're exporting. So as I've mentioned before, if I go back here, let's say we're processing a class and, somewhere nested deep, like let's say, this num variable was an actual integer, and then that integer had some fields in it that basically somehow ended up referencing this class again, this exact same object. I basically have a concept of references. So if we look at this from a practical standpoint, let's say we have a class of B. So I create a class of B, and class of B has a field underscore A of class A. And here, let me do this. And let's say I had an underscore of B, and then B is equal to class of B. Now, if we picture this as being an actual object, the structure of this is going to be class of B. B maybe, let's say, references A again. So then we'll have class of A inside of this object, and then that will then recursively contain all of the information that A already had. So it'd have, the num, the object, and then B again, which would then continuously reference the same object. So the way I do it is I have a concept of references. So I have a ref ID given to every single object. And whenever we go nested deeper into a different object, I create a new reference ID. So I say ref ID number 2. And now when I get to the point to where it wraps back around to the original object, I check to see if we have a ref ID that matches the pointer that this object is pointing to. So this object is going to have a pointer of, 0x100, right? Let's say that's the memory address or the memory location of this actual object. This one, let's say it has a pointer memory location 0x200. When this one comes down here and it has a pointer of 0x100, I'm going to say, oh, look, I already have a pointer of 0x100 added to the list. That has a reference ID of 0. So instead of dumping all the crap that's in that data structure into the file or into the bytes of memory, what I'm going to do is just say reference, the reference ID of number 0. And then that's basically going to represent this pointer here that we can then reference later when we build this object back again. So hopefully that made sense. I'm going to actually go back here and get rid of all this crap. But yeah, so that's pretty much how it works. So let's go back into the source code. So let's just kind of go through everything. So for the cleanup, I basically set the data stream, which is a string stream, back to empty. And then I free the stream info. The stream info is going to be a key pair list. It's going to have an integer, which is going to represent the ref ID or the reference ID. And then it's also going to have the pointer to the actual object that I was talking about. So this is going to be the pointer to each object that we're going to be referencing, because if you remember, every time we create a sharp object, if I go here, every sharp object basically has a list of nodes, which are objects which then contain pointers to sharp objects. So that way we can keep track of all of our pointers. So if I go back here, and then once you do that, then you want to set up the export object, which is going to take a sharp object, And then every time I call into here, I want to increase the recursion limit. The reason why I want to do this is because we want to keep track of this ref ID. So that way, every time we come in for the first time, I set the reference ID equal to 0. Now, I could just do it in the cleanup. This is just kind of, yeah, whatever. It's fine. You can do it in cleanup if you want, but this is what I'm doing. Now, if the object's size, so if we have a pointer and the object size is greater than 0, that means that we have data to process. Otherwise, I basically just throw a null pointer exception. I free up the data and that's it. So now in the case where we have data, basically what I do is I start out every data string with an export secret. So the export secret is going to be 0x1a. This is again just a random value that I just made up. I just typed a bunch of random numbers in my keyboard and whatever came up is what I picked as the value. So you want to make sure that none of these values clash though, because that would be bad. So that's the only concern. But I have the export secret. After that, I have the type, and this is going to be a char. Now, you want to put it as a char because you don't want to take up too much data, right? If you just pass the type, it's going to be a number. Let's say the type was, I don't know, the value of 10. You're going to take up 2 bytes, 1 and 0. So you don't want to do that. Just put it as a char, and then you can just read the value afterwards. As long as you have a number less than 255 for the type, you should be okay. Once you do that, then you want to add the size, and I have a char of data in, which basically represents the end of any data in the stream. So mine is 0x2. That just means that that's the end of the data. I could have used 0x0, but whatever. This is what I did. So there's that. And then here's where the magic happens. So I increment the reference ID. So every time when I come into here and add a new piece of data to the stream, I pass it the reference ID and increment it so that way the next object has a new reference ID. And whatever the value is, I mean, objects can be nested pretty deep. So I just put this as an actual number and then I end the data here. And then I actually add it to the stream info by creating a new key pair. I pass it the reference ID -1 because I did increment it here. And then I pass it the object, which is going to be a pointer to the actual sharp object that we just added. And then when it comes to vars, right? So I support any object in the programming language. So literally, if you wanted to export, let's say n was just an array of numbers. If it was 1, 2, 3, you can export that into a file. You can export it into a byte array or whatever. You can also export objects as well. So if it's just a straight object, and object's basically just a way to obfuscate the type. So it's the same thing. So you can also do that as well. But the structure of how these things are handled in memory are completely different. So it's really going to depend on your system and how you build your virtual machine and how you structure your objects in memory. So keep that in mind when it comes to actually exporting your data. So I check to see if it's a var, which means it's just a number type. I pass it the numeric type of the value. If you guys remember, this can be var, int32, 64. This int type basically signifies the type of number that this array or this sharp object is. Then I say export data. Export data is a value of 0x5f. And basically this just represents or tells the export system or the import system to say, here's where the data starts. So, I have all this preliminary information about each type of object, but this signifies the data is about to start now. And for int 8, so if it's an int 8, I basically just get the string value, and then I print that out, and then I end it with a char. So I do this because it's a lot faster to do it this way than to literally print out each value with 16-digit precision to the string, because doing this way is really going to take up a lot of bytes. If you have like a 1 million size object and you're printing out 16-digit precision, that's basically 16 million bytes or 16 megs just for that one array, which is ridiculous. So keep that in mind. I'd recommend trying to figure out the most compact way to actually print out your data, but you don't want to lose precision. So I have to kind of do this if it's a bunch of numbers, because I don't want to lose precision in the actual hard values of each array. So yeah, there's that. And of course I end the data on each of these. And then after that, I say export end. So this basically signifies that the export has ended. So this signifies the start of the data. This signifies the end of the data. And then I basically just return the data string, which if you guys remember, if I come back out to here, that is basically returned to this string right here, which takes that string value and constructs a native string and then, puts it out to this object. So if I go back here, Once we converted our var to a type, then let's see what we do for classes. So if it's a class, so first I check the info to see if it's a class. If so, then I basically get the class from the system, and then I basically set the data stream to export class. This has a value of 0x2b, and this basically signifies that we're exporting a class. After that, I want to set up some data. So I want to get the start of the field address. If you guys remember, fields, the way they work in my programming language is as I load them in from the executable, I'm going to have this array of fields. And what's going to happen is we're going to start out with our instance fields first, and then we're going to have our static fields second. And it's going to be exactly in this order, so that way it's easier for me to basically for loop in the event I need to process a class in a specific format. So keep that in mind when I'm doing this. So basically I'm getting the start of the field address in the field's pointer. If it's a static field, I basically check the generation to see if it's a permanent generation. Typically, classes or objects with permanent generation are static objects. So what I do is I say the start of the pointer is equal to instance fields, which is basically the count of how many instance fields are in the class. So if I have, 3 instance fields in the class, then I want to start at the third index because that's where the static fields are going to start after that, if that makes sense. Otherwise, if it's an instance field or an instance class, I start at 0 because instance fields starts at 0. As far as field size, I basically return if it's a permanent generation, how many static fields we have. Otherwise, I return how many instance fields we have. And after that, I put the class name, so kind of just like Java. I print out the exact string value of that class. I end the data with our data end. And then I say export data because this is where the data actually starts. So classes are kind of complicated, so let's just go through it. So I put whether or not this is a statically created class, and then I return whether or not this class is an array. Now, if the field size is not equal to the object size, then I basically throw an error saying incompatible class exception, class whatever, size does not match the field count. Now, this is important because literally what could happen is the risk of doing this is that literally a person can export a class out to a file, go into their source code, change the structure of that class, recompile their source code, and then later on try to re-import data from that file, and you have a completely different class. Do not want that to happen, so to protect against that, I have this small check here where I check to see if the field size is not the same. Now, I know you're thinking, well, that's fine, right? But literally, what if we have like 3 fields, each fields are integers, and then I just go in and change all of those fields from integers to strings? We'll see how I protect against that as well. So what I do is I check to see if the class is an object array. If it's an array of classes, then I just for loop through each class. I get each object or each data set out of that class. Now, if the data set is not equal to null, I call export object, which literally recursively calls back into this function. Otherwise, I print out to the stream what's called an export empty. That's going to be 0x6c, and this basically represents that there's no data to be exported, basically. So there's nothing. Now that's for if it's an array, and that's fine, right? But what if it's just a regular class and not an array? So in the event that it's a single class, I for loop for the size of the field size. Now notice I for loop through the entire size here. In this case, since it's a single class, I'm going for the amount of fields that it's supposed to be. And I know that this is going to be the same thing as the size because I literally just checked it up here. Now, this is actually a bug that I literally just found or realized like 2 seconds ago. So if it's an array, you want to for loop through the size. Now, if it's not and it's a single class, you want to do this field size check against the size of the object inside the code where you're compiling it if it's a single class. So yeah, and basically I for loop to the field size, I get each field out. So I access the fields array, and again, I start at the field address of wherever we need to start, and I plus it from there. I access a reference to the field, and then I export the field's data. So I say export field, which is 0xd. That's the value that I picked for that. And when it comes to exporting a field, I basically set the field type, which is the type of the field. So that's going to be whether or not this field is an int 8, 16, whatever, right? And this is where that check is going to happen, right? So if you literally have like all integers and then you switch it to a string, obviously that's a problem. So we're going to cross-reference this, but this isn't enough information because what if you have all classes of like class string and then you switch all the classes from class string to class int? We also need to protect against that as well. There's a lot of nasty stuff you can do when it comes to restoring the state of objects, and you really want to be very careful because if not, you can literally crash your entire system and get a seg fault because you're trying to access memory in a specific way, and the data that you imported was not in the same format as when you exported it whatever time ago. So yeah, basically I add the type, I end the data. This is just going to print out the numeric value. I set the field's name in the data, and I check to see if the field's node at I and the object value is equal to null. Basically what this does is this checks to see if the field's value is null. So I'm checking the object's node at I, which is basically the index of that field that we're processing. If it's null, then again, we just say export empty. Now, otherwise, if it's not null, here's why I do the magic check to see have we already processed this information. Now, what I do is I get the index of the data by checking the stream info and getting the index of the object that we're trying to process. So I access the sharp object, which is going to be pointing to the actual object of this field, and I traverse the list and I check the find object function. That's going to basically pass in the sharp object that's a void pointer here, and then I just convert it to a sharp object. I check to see if that's equal to the element.value, which is this sharp object here, and if so, I return true. Now, at that point, what the list class is going to do is it's going to return the index value of the point at which we found that data, and if the data is not found, I return -1. So what we want is we want the value of this return value to be -1. So if the index is -1, that means it's safe to export this object. Otherwise, I do what's called an export reference. So this is going to be 0x4b, which is just a random value that I picked. And in order to export a reference, I just get the key value, which is going to be the numeric value of that reference. So that's going to be this portion right here. That's going to be the numeric value of the ref ID that we set at the very top of every single object that we export. If I go back, once you do that, then you just end the data. You want to put the exact number here. So I just print it out as a number and then I end the data. After that, I've successfully processed the class and I end the export, and then I just return the string value of the actual data stream. All right, so let's see. So we've gone through the case where it's a number. We've gone through the case where it's a class. Now let's go through the case where it's just an object. We don't know what the data is. So the way it works for objects is I say export data, because this is where the data starts. Then I for loop through the entire size of the object. And again, I check to see if each node or each object in that array is not equal to null. If it isn't, then I export that object. Otherwise, which recursively calls back to the function, otherwise I say the export is empty and that's it, and then I end the export. And then I minus recursion here, and that's a bug as well. Okay, so every time when you return from the function, you want to subtract the recursion because obviously you're returning out of the function. I'm going to do that later. I'm not going to do it now. But yeah, so you want to make sure you update the recursion value. Now, to be honest, I think you could just remove this because I actually don't even use the recursion like I used to. A better way of doing this is literally just delete this object, set the ref ID to 0 every time you clean up or call the cleanup function, and just leave it alone. That way you don't have to think about any of this crap. So yeah, I wouldn't use this if I were you, but yeah. Now, if we get down here, we just return blank. We never should get down to here because if it's null, I throw an exception. And if it works, I return the string, and if there's an error, I throw an exception. So ideally, we shouldn't get down to here, but just as a precaution, I do it anyway. Now, after that, we have basically all of the source code that basically pertains to loading an object, and it's quite a lot of source code. So let's go through everything. So when it comes to importing an object, I actually start out calling this function first. So what I do is I check to see if the object we passed in is of type var and the object size is greater than 0. Now, why am I checking to see if it's a numeric value? Because the object that's passed in here is expected to be a stream of bytes, or in other words, a underscore int 8 array of data coming from the high level from who the heck knows where. So once we do that, then I set the position equal to -1, and the position is going to be a thread local. Now, if you guys noticed, I'm actually going to scroll back up here. Both of these values, like the recursion, ref ID, and this key stream info, these are all going to be thread local values, because if you're going to be having multiple threads running on your programming language, you want this to be a thread safe call. So you want to be able to export and import objects on multiple different threads without ever being disturbed at all. So just keep that in mind when you're actually writing the source code. But you want to create a thread local of position and stream size. And then, I mean, there's a bunch of like functions here. We'll get to those helper functions in a second. So when it comes to loading an object, if I keep going back down because we didn't talk about it all the way, I basically set the current value, or I basically add a value onto the stack based off of whatever is returned from this load object value here. And then I free up the stream info, which isn't necessary anymore because I'm going to call the cleanup function once I get out of here. So let's actually look at the load object function. So first, I'm going to basically just get the data off of the sharp object, which is going to be the int8 array of data that we're going to be looking at. And I check to see if the data at position plus plus. And the reason why I set it to -1 is because you want to always process the position of data in real time as you're processing it. So basically, I just increment plus plus to get the current character that we need to process. So it's just a way that I do it. Now I check for the export secret. If we don't have the export secret, then I basically say export secret not found, and I throw an object import error. Now this is going to be a new exception that I created in the programming language, so you guys can create whatever exceptions you want. But basically in the virtual machine, I now basically had to add a bunch of other classes when I set up and resolve my virtual machine. So I added the incompatible class exception and the object import exception to the programming language. You also want to make sure that you update your dependency files as well. So if I go here to the platform dependencies, you also want to make sure you update the dependencies file so that way if the code gets obfuscated, you're not screwed basically. So once you do that, then you're good to go. So if I go back here, so assuming that we have the appropriate data, now we need to unpack or process the data that we just received. So first, we get out the sharp type of the type of the object that we need to process from the data. So we just say data at position plus plus. We get the size of the data, and I call a function called readInt. Now, I'm going to go over all these functions now so we can just get them out the way. They're not that complicated. Basically, we have next char, and just basically get the next character off of the data stream. So I say position, I return a char here. I say position is less than the stream size, and we set the stream size based off the size of the object when we first processed it, and I basically just return the data at plus plus position. Otherwise, I say index out of bounds exception. Not enough data to process the object stream. Is the object possibly corrupt? So that's my little error. You can add more data here, like, what's the position of the data and, the stream size or whatever if you want. But the user shouldn't have this issue anyway unless they put some garbage in here. So after that, I have a function called peakchar, which you pass in the data again. Then I check to see if we increment the position, if it's less than the stream size. If so, we're good to go. I return the data +1. Otherwise, I return 0. When it comes to reading an int, basically I pass the data, I create a string stream, I for loop indefinitely, read every single char or the next character, and remember, we never have to worry about going out of bounds of this data array because we're protected by the size of the actual object that was set when we started processing it for the stream size. So I just continuously get the next character, and I check to see if the character is equal to data n, which again is 0x2. And basically, if so, I break out of this for loop. Otherwise, I keep adding the data to the actual string stream. And then I just basically return string to long long, which takes a string stream and converts it to a C string. And yeah, so I convert the data in here into a long long. For converting it to a string, I basically do the same thing where I get the next character, check to see until we're at the end, and then I just return the string value of whatever the string stream has. Now, when it comes to reading a double, what I do is I for loop through the data, and I basically get the next char, same thing here, and I do string to double, and I get the C string here, and that's pretty much it. Now, when it comes to reading a string, this is kind of a bad way to do it. So what I would recommend is actually before you actually start processing strings, I'd recommend adding what's called a data size, and I don't know, give it like a value of CA or something, 0xCA, and then I would recommend putting the data size here for strings. That way you can have a string with an indefinite length, and let's say the string had the value of 0x2 inside of it, then you don't screw yourself by thinking that you're at the end of the string because the string had this character in it. So I'd recommend doing something like that if I were you, but this is what I have. That's for a future update. But yeah, so if I scroll down, next we have expect char. So to expect the character, I pass it the data, I pass the char that I want to expect, I increment the data, and then I check to see if that data is not equal to char. If so, I say expected char whatever during object import, and that's pretty much it. And I put the integer value instead of the char value because I'm going to be expecting like I don't know, export empty or whatever like that, they're not going to be legible characters, right? These are just random values. These aren't like letters. So keep that in mind. But yeah, so those are all of the preliminary functions that we need to get everything working. Now let's actually see what we do. So once we get all of our first sets of data, if it's a variable, I first pull out the type. I expect the char of export data. I get the object and I basically create a new object and I pass it the size and the numeric type of that data. I add this data to the stream info list. And again, even when you're importing data, you also want to still use the concept of stream info. That way, I'm passing the data of the reference ID. So when we get down to a point to where we actually have an export reference, we can literally just access this list that we're assigning up here and pull out the sharp object that was passed into the list at an earlier time. I increment the reference of that sharp object because if you guys remember, just because you create a new object, the reference is not incremented, so the garbage collector basically might try to destroy it. So we don't want that to happen. That's really bad. So I increment the reference, and then I check to see if the end type is equal to int8. If so, I read the entire string, and then I just basically set up the data. Otherwise, then I basically just read the data by reading a double, which is going to be a 16 precision double. And then I expect the character of export in because obviously this is the end of the data. I decrement the reference of the object and return the object. Now it's perfectly safe to have an object with no references for a very short amount of time because if you guys remember, the way that the garbage collector works is it has to mark that object first and then it tries to free it up. So it has to traverse through the entire memory system, which is going to take some time. Not to mention the garbage collector does not run every second anyway, so it's totally fine to have an object hanging with no references for a short period of time. So after that, now if the type isn't a var, I check to see if the next character is equal to export class. This is why I added that character. If so, I increment the position to eat that character. I get the class name by reading a string. I call this function vm.resolve class, which basically tries to find that class with that name in the classes list. Now it has to be the full name. So when you put the name of the class inside of the actual data stream when you export it, please make sure you put the full name. Otherwise, it doesn't make sense, right? You can have a million integer classes and they can be all in different modules. So you want to put the full name. That way you know it's not a duplicate. And if the class is not equal to null, we process it. Otherwise, now this is where it gets to that interesting part. So what if you export a class and then try to import that class, but your current source code literally does not have access to that class because maybe it was obfuscated or maybe that class was removed from the source code, then obviously that's a problem. So then if that's the case, we'll say class, we put the class name, could not be found in the object stream, and then we say illegal state exception. Now, if we actually have the class, then we expect export data. We check to see if this is a static initialization and whether or not this is a class array. We get the real size of the class by getting the static fields or instance fields based off of whether or not this is a static initialization. Now, if it is not an array, I check to see if the size is greater than the real size. So here's another check or safety check that I do when it comes to importing data. So if the current size that this object, is supposed to have, meaning that we're trying to import an object with 5 fields, but the actual size of the object in memory currently only has maybe 4 fields, that's obviously a problem because it's literally impossible to import this class because it's bigger than the class was. So the way that the import system works is literally like, let's say I have a class called A, and A has 3 fields. If I add 5 other fields to that class and I try to import the A class, it's going to work perfectly fine. It doesn't care about extra fields that are present. It only cares that it has the fields that was exported at the time that the class was created. So if they're less than that, then that's a problem. So keep that in mind. And if that's the case, then I say class whatever requires whatever fields when the class was found to only have whatever fields. So, it's going to tell you that, this class has X amount of fields and, before, and now it only has X amount of fields. So we create the object of the single class. We pass it the class value, whether or not it's a static initialization. And I have this field now called auto init for classes. This is new. So what this auto init does is, if you guys remember, whenever we created a class in the garbage collector, I checked and for looped through the entire class to check to see if the field was an integer. And if it was an integer and it wasn't an array, I would basically instantiate that object to basically set those values to 0, so that way integers or native values always had values. But in this case, because we're literally loading an object from memory, it doesn't make sense to do all of that work just to reset these objects immediately afterwards, because they're going to have different values. So if auto init is set to true, I do this, otherwise I don't. Now in this case, since we are initializing it, I say auto init to false, and the default value for auto init is set to true. So any other places in code where I'm using this new object function, I don't have to care. So that's why I did that. Now let's see, so if I go back here, once we initialize the class, again we add this object to the stream for specifically the fact that it's a class. So then we increment the reference of that object that we just picked up, and I basically for loop through the size. So I for loop through the size of the class, I expect the export field, I get the type of the field, I get the field name, and then I call get field. And again, this is another protection mechanism where I basically call get field, which basically passes it a name of the field. Now for the fields, you don't need to pass it the full name, because if you remember, in a single class, you cannot have two fields with the same name. So that's not a problem we have to care about. We do care about whether or not the field exists. So we're going to try to access that field pointer in that class. And let's see, that's debugging code. If we cannot find the field, I'll say field whatever was not found in class whatever in the object stream, and I pass an illegal state exception. So otherwise, if I scroll back up to the top, now if the field's type is equal to the field's type, we're good to go. Otherwise, I say field whatever does not match type, and then I convert the data type of the field to the actual string, and then I say found in the object stream. So I'm basically just passing in the type of the field and whether or not it's an array, and it converts that value to whatever the type is, and then it puts the brackets if it's an array. So I do that, and then I also, to another check set, there's tons of checks in here because you want to make sure it's good. So I basically access that field object by resolving the field in that class. So I say VM resolve field, I pass the field's name, then I pass it the reference to the actual object that we created up here. That's literally going to do the same thing that we just did, but instead it's going to get the class, for loop through the entire class, access the field, return a reference of that field. Otherwise, we're going to get a null pointer if it can't find it. So this literally is the safest way to do it. Now, obviously, I could have just accessed this object at whatever index, but I'm doing this for safety reasons. Now, if I peek the next character and it's equal to export empty, obviously this is a null field, so I just increment the position, set the field to null. Now, this is kind of unnecessary because the field's already null, but whatever. That's what I'm doing. And then I check to see if the next char is an export reference. So if so, that means that we need to instantiate this field based off of a reference of a previous object. So I get the index of that reference off of the stream info. If the index is greater than 0, then I say field object is equal to the value of that data in the stream info. And it's literally just going to call a function where we just pass it a sharp object, and it's going to do whatever it needs to do to assign that object and increment the reference on that sharp object. Now, in the case where the index is less than 0, I say could not locate object with reference of reference ID in the object stream. Now, this should never happen, but again, I'm just being super safe about this. Otherwise, if not, then I recursively call back into this load object function to load that actual object. Now, once we get done with all of that, this is the case where it is a class array. So I'm literally just getting the object array here, and I'm passing it the class value and the size. Again, adding this value to the stream info, incrementing the reference, for looping through the entire class. Now, if you notice, I incremented the reference here, but I didn't decrement it at the bottom because I'm also incrementing it here as well. So I just decrement it once, so I'm not repeating code unnecessarily. So I increment the reference, I for loop through the size of the object, I check to see if the next char is equal to export empty. If so, I increment the position. Otherwise, I set the node or the array value to the next loaded object. And once that's done, then I expect the char of export in for both of these values, because obviously it's the end of the export. I decrement the reference and I return the object. Now, in the case where it's just a flat object, I literally expect the character, create a new object array of size, increment the reference, for loop through the array, check to see if the export is empty, increment position. Otherwise, I assign the node at whatever index equal to the next loaded object. I expect the char of export end, decrement the reference, and return the object. So that's pretty much everything, guys. This is how I import and export or serialize and deserialize objects in the programming language. Now, obviously, this is the first pass. You can do other stuff as well, like you can do Json serialization. So once you have your system in place in your programming language, you can basically serialize the JSON, you can serialize the XML files, or any other type of file or data set that you want to export to. So sky's the limit, guys, when it comes to doing this. It's not super difficult to try to do this. You literally just make up a bunch of characters and a basic framework, and then you can kind of set it up yourself. So that's going to be it for today, guys. Hope you enjoyed the video. I know this was really long, but I wanted to get it all out in one video instead of having like part 2, part 3. And yeah, so if you guys have any questions, as usual, definitely put them in the comment section below. And of course, if you're new to the channel, definitely consider subscribing. And until next time, I'll see you guys later.